In this video, I want to take a step back and briefly talk about architectural drawing systems, specifically projection systems. In architecture, drawings are not just images, they are systems of representation. To understand plans, sections, and elevations properly, we first need to understand how architects project three-dimensional space onto two-dimensional drawings. For this introduction, I'm referring Architectural Graphics by Francis D.K. Cheng, particularly Chapter 3, as you see in the screen, which explains projection systems and how architectural drawings are organized conceptually. And in this video, I give a brief overview of projection systems with a focus on orthographic projection because this is a system that plans, sections, and elevations belong to. Once this framework is clear for you, everything we do later in Rhino will make much more sense. In architecture, orthographic drawings are commonly referred to as plan, section, and elevation. This book explains the language of architectural drawing, not software, but ideas. What a plan is, what a section is, and what an elevation is, right? So, in this page, as you see the plan, right? So I'm going to explain what a plan is. A plan is a horizontal cut through a building or object. Imagine cutting a building horizontally and looking down. This is often called the floor plan. And now what a section is. A section is a vertical cut through a building or object. Sections reveal interior spaces, heights, relationships between elements. If you cut a building vertically, the resulting drawing is a section. What an elevation is. An elevation is a flat, vertical drawing that shows one side of an object or the building, right? Or a space. An elevation is an exterior orthographic view, right? So it shows one side of the object or building, height and proportion, surface and scale. So elevations are not cut drawings. They show the outside of the building or the object. So plan, section, and elevation are all types of orthographic drawings. Okay, let's go back to isometric projection. When we talk about projection systems in architecture, not all drawings work the same way, right? Different projection systems represent the space differently, and each one serves as a specific purpose. One important group of projection systems is called isometric projection, which is sometimes referred to as parallel projection. In isometric drawings, the edges of the object remain parallel to each other, and there are no vanishing points, right? As you see in here in this page. This means the drawing does not try to imitate how the human eye sees space. Instead, it represents form in a clear and measurable way. So, isometric drawings allow us to see multiple sides of an object at the same time, which makes them very useful for explaining spatial relationships, right? Let me go to the next page. There are three types of the isometric projections. As you see, we have isometric, dimetric, trimetric, right? So I'm gonna just go to the next page in here. So I'm gonna explain briefly isometric, dimetric, and trimetric. A common type of isometric projection is isometric projection. In an isometric drawing, the object is rotated so that its edges are equally angled, right? Typically at 30 degrees on both sides. As you see, they are equal, right? A common type of isometric projection is isometric projection. In an isometric drawing, the object is rotated so that its edges are equally angled, typically at 30 degrees on both sides. So as you see on both sides, they're equally angled in isometric projection. So as you see, all three dimensions with depth and height are shown at the same scale. So isometric drawings are often used because they are relatively easy to construct, and they clearly communicate three-dimensional form without distortion from perspective. Other types of isometric projection include dimetric and trimetric, where the angles and scales of the axis vary. But the logic remains the same. It means the edges stay parallel, right? And there are no vanishing points. Another projection system used in architecture is oblique projection. In oblique drawings, one face of the object is shown directly, right, and at through a scale, while the depth is projected at an angle. This means the front face appears flat and undistorted, while the sides recede diagonally, right? You see in this page. Oblique projections are useful when you want to clearly show one primary face of an object while still suggesting depth. A common variation is sometimes called a plane oblique or military projection, which gives the impression that you are looking down at the object from above, combining plane information with vertical surfaces. Like isometric drawings, right? I show you. Oblique projections do not use vanishing points, and the edges remains parallel. That's all about isometry. In contrast to these parallel projection systems, perspective projection represents the space as we see it in real life. As you see in this page, in perspective drawings, parallel lines appear to converge toward one or more vanishing points, right? So objects appear smaller as they move further away from the viewer, and creating a sense of space and depth that feels realistic and photorealistic. So perspective drawings are often used for visualization and representation because they reflect human vision. And there are different types of perspective projection, including one-point perspective, two-point perspective, and three-point perspective, depending on how many sets of edges converge towards vanishing points. In contrast to these parallel projection systems, perspective projection represents space as we see it in real life. As you see in this page, in perspective drawings, parallel lines appear to converge toward one or more vanishing points, right? So objects appears smaller as they move further away from the viewer, and creating a sense of depth that feels realistic and photorealistic. So perspective drawings are often used for visualization and presentation because they reflect human vision. And there are different types of perspective projection, including 1 point, 2 point, and 3 point perspective, depending on how many sets of edges converge toward vanishing points. Understanding these projection systems helps clarify why architects choose different types of drawings. And so each system communicates space differently.